Okay, another of the same, but there ends up being three of them. That's the only difference here. So three dy dx's will be created, but you handle it exactly the same way. So we'll have a 3y squared. So you just go as if it's a normal thing, but since you're taking the derivative with respect to x, chain rule must happen. So dy dx. Remember, everything's supposed to be about x. And when it's not, a dy dx is going to be required. Now, this one's interesting because it will be 5, but you have to remember it's still a chain rule because that was not in terms of x. Okay. And then, oh. I got it. Minus. And then 2x because, sorry. Got it. I got it. There. Well, it looks like it wants to. Okay. All right. Anyway. All right. So equal. Goodness gracious. All right. So minus 2x and then equals 0. So the only thing to move to the right hand side will be the 2x. And then everything else stays over here. All right. So that's just staying. So I see that all three of those have a dy dx. So I'm going to go ahead and factor. So dy dx times all of that, 3y squared plus 10y minus 5. And then I'm adding the 2x to both sides. So adding the 2x to both sides, and there we are. And now the only thing left to do is divide by everything inside that parentheses. And so dy dx then will equal this crazy looking thing. It will be 2x in the numerator, and your denominator is all of that mess. So 3y squared. And this time we're not asked to substitute anything in. And a little notational thing there. If we were, if we did have to substitute in, we would just have to put the little bar and then what the ordered pair is. You wouldn't have to write the x comma y like I've been doing. That's been a little bit too much and not necessary. Okay, let's get 4 while we're here. So this will be 4. We have a product. Okay, so there's the first. Okay, and then there is the second. So this is two things multiplied together. So we'll go blue this time. All right, so here we go. So the yellow, the first, all right, times the derivative of the second. The derivative of the second is e to the x. Derivative of e to the x is just e to the x, which is kind of crazy, but true. Plus the second, which is e to the x again, and then the derivative of the first. But the first is simply y. So the derivative of y with respect to x will be dy dx. And then the right-hand side is a constant. That's not a variable, a constant. So the derivative of 3 pi with respect to any variable is 0. All right, and then, so get everything that doesn't have a dy dx over to the right-hand side. So I have an e to the x dy dx. All right, equals negative y e to the x because I am subtracting that from both sides. And then divide both sides by e to the x. But hold on. If I do that, if I divide both sides by e to the x, I'll show it the first time. So negative y e to the x over e to the x. And then the e to the x is just going to cancel. This e to the x thing is just wild. And so those two just cancel out. And my answer, the slope is always just the opposite of y. Well, how about that? That is crazy.